So volume of spheres and surface area of spheres as well. Here's the formula. It's right here. Make sure you can identify the radius. That's the only thing that gets plugged in, which is so nice. 4 times pi times 2.5 squared. So these are separate questions as well, and that I feel like always confuses people. So 4 times 2.5 squared. This is going to give you 25 pi. The answer in terms of pi, 25 pi, or you can multiply it by pi and get 78.5. It's the same thing, but remember we need to know how to answer both ways. Also, surface area is squared. And this is kind of a weird formula. I tried to look up some sort of YouTube video to help explain how this works, but they were all like 20 minutes long and really boring. So it's like, we don't need that. But essentially, pi r squared finds like a quarter of this, which is weird because it's like that's also the area of a circle. But if you end up multiplying it by 4, then it finds the total surface area of the entire sphere. Also, just make sure you realize that you got to cut the diameter in half. 4 pi 5 squared. This is the diameter. Don't accidentally put that in the calculator. So 4 times 5 squared. Oh, that's not right. 4 times 5 squared. That's the right button. Is 100 pi. And that would make this one 314.2. Just moving the decimal on pi 2 times. But yeah, units squared is what this is. All right. This is working backwards, which yesterday I know there was one that was a bit of a struggle on working backwards. We're going to, again, work backwards today. This formula is a little bit easier. And then the volume formula is similar to what we did yesterday. But we have the volume, which is 50, equals 4 times pi times the radius squared. And every single time, so this is one of the times where I'm like, pay attention as I put this into the calculator. Because you're going to do it maybe 2 different ways in one of the... Over 4 pi. Great. That gives you the answer that you need. The wrong way, 50 divided by 4 pi. That is not the same number, so don't do that. Okay? What happens here is it says 50 divided by 4 and then multiplies that number by 5, or by pi. 50 divided by 4 multiplies it by pi. You don't want to do that. You want to, so you got to do one of 2 things. Either put it in this fraction bar thing, or 50 divided by parentheses 4 pi. Both of those methods will get you the correct answer, but, you know, don't do it. Do it correctly. But every year somebody puts it in wrong. Either that or you could divide by 4, then divide by pi separately. That works too. But you end up getting 3.798, and we need to take the square root of that number. So you're ultimately going to end up with 2. I'm just going to put 4 here, and then you take the square root of that, and you get 2, because at the end you're going to round, and it will round to 2. But this is really just 2 steps. You divide by 4 pi, you take the square root, and then that's it. All right, let's move to this one. So 4 times pi times 3 cubed divided by 3. If you miss this, it's probably because you do r squared instead of r cubed. That's like the main thing. Make sure you know how to do this. So I'm going to show you how to do this in the calculator. I'm going to put this fraction bar there. I'm going to do 4 times pi times 3. And then how do you make it cubed? This little caret thing. That is going to bring it up. And there may be another way to do it, but I think this is easy. And you divide that whole thing by 3. But if you want it in terms of pi, so this is, blah, I don't want that. I don't know why I put 9. 3 right here, 0.1. And this is units cubed because that radius is cubed. If you want it in terms of pi, do the same thing, take the pi out. and it becomes 36 pi. Or 36 pi units cubed. Okay, practice putting that in the calculator. Sometimes it doesn't end up like a nice pretty whole number when you're answering in terms of pi. Also, if you put 8.4 in there, it's wrong because it gave you the diameter. So fix that. Make sure you pay attention to that. Yeah, this is in terms of pi. I kind of switched them from here, but same idea. All right, find the radius if the volume is 400. Okay, same idea as before. This is 400. This is 4 times pi times the radius cubed divided by 3. All right, we briefly talked about this yesterday. We're going to do the same thing today. I'm going to get rid of this fraction. So I'm going to multiply by 3 on both sides. 1200 equals 4 times pi times the radius cubed. Now it's very similar to the problem above. So 1200 over 4 pi. Notice I'm putting it in this little fraction thing so that it doesn't mess up. All right, and then I get this number. I'm not going to round it yet. So 95.49, and then it just is going to go on. And that's r cubed there. So how do you take the cubed root? All right, how do you take the cubed root? So I am going to... Oh, I forgot. Maybe it's in math. Maybe it's somewhere else. Okay. Click on the math button. And that's the cubed root. Okay, so I'm going to do that one more time. Math. Cubed root. This number. So you end up getting 4. We're just going to, at the end, round it to the nearest tenth. 4.6 for the radius. I think, I'm not sure, but I think in the one that you'll see, it may have pi in the answer. This may have supposed to have pi. But if there's pi in that volume, you need to cancel out the pi's so that they disappear. But in this case, it didn't. We did one like that yesterday. We were canceling out the pi. Okay, here's this one. And this one, oh my gosh. This one just throws everybody off, like, every single time. So the surface area, okay, the volume of a semicircle is not as big of a deal because it's literally you just take that final answer and you divide it by 2. It's really easy. Or instead of multiplying the top by 4, it's 2 pi r cubed divided by 3. That's the volume of a semicircle, or not a semicircle, a hemisphere, half of a sphere. But the surface area just throws everybody off. Okay, so that formula, you are going to do, think of it, 4 times pi times the radius squared is half of a circle, or is a whole sphere. So we need to cut that in half, right? How would one cut that in half? But we're not done, okay? Because a hemisphere has a circle on the bottom, all right? Here it is. This is a hemisphere, minus this piece. You also have to account for that circle. So you then add the area of a circle, which is pi r squared. So we actually have 2 pi r squareds and another pi r squareds. So you end up with 3 pi r squared. That is the formula for surface area of a hemisphere. But the problem is people forget about that bottom circle. So they do the 2 pi r squared, and then they forget about that bottom circle, and then they get it wrong, and it's sad. So if the radius, we're just going to do this first one. I feel like we can cross this one out, but we're just plugging into the formula. 3 pi r squared. 3 times pi times 2.5 squared. 3 times 2.5 squared. So it's 18.75 pi. or 58.9. So that gives you the surface area of this like dome part and the surface area of the circle below it. If the radius of the surface area is 74, so same idea. 74 equals 3 pi r squared. Divide 74 by 3 pi. Oops. And then it just, you know. Okay, I divided by 3 pi. Divided by 3 pi. And then I just need to take the square root of that number. Why am I taking the square root? Because this is r squared, and we want just the radius. So 2.8 is going to be that radius.